I was just thinking about a situation, and it was an interesting one because it got me thinking because the problem it seemed simple on the surface, but it actually took me surprisingly kind of a long time to figure out the solution, and it kind of got me thinking about um, just the whole philosophy of using uh, concepts of code and computer science to do art because I think fundamentally there's this friction because basically the things that humans are really good at and that are simple to us are actually really hard for computers. And the other way around, things that we have a really hard time doing, computers do really easily. Like for example, if I need to add up all the numbers uh, 0 to 100, it would take me a long time to do that, right? I'd have to go, okay, 0 plus 1 is 1, plus 2 is 3, plus another 3 is 6, right? And that takes me a long time, but a computer can actually do that stuff very quickly. So in that type of situation, the computer is quite a bit stronger than the human. But if I let's say I have a piece of geometry here, and even if I went up to a 5-year-old and I said, "Hey, can you point to me, you know, where the ends are?" The 5-year-old would probably say like, "Oh yeah, right here and right here." Right? It's just something that we just take for granted that we can understand that so easily, right? And so I think like one thing that's really kind of it could be a source of frustration, but it's just kind of something that um, uh, if you're aware of it, you can avoid it. Is thinking that the computer sees the world the way that we do. So let me give you an example. So if we wanted to color the ends of this strip of geometry black and then color the middle part white, we could go up to like a 5-year-old and say, "Hey, go ahead and color the ends black and color the middle white." Now they might color it pink just because they're 5, and but they probably would be able to follow those instructions. So we think, okay, well, my gosh, that's so simple. The computer should be able to do that. So we drop down a color and we say, okay, let's go ahead and make you a color ramp. We'll do a ramp from attribute, and we'll go ahead and make the ends black. So we'll bring this white to the middle here, and we'll bring this here. So there you go. So the ends are black and the middle is white. Okay, cool. It's not cooperating. And see, this is where you kind of get into a little bit of trouble because you could you could think, well, I mean, come on, computer. I mean, I'm obviously telling you, look, the ends are black and the middle is white. Aren't the instructions clear? And the computer has no idea what you're trying to tell it to do, right? So then you say, okay, let's see. Oh, ramp from attribute. What attribute could we use? Well, maybe the X position, right? Um, because that's one way of thinking about it is this horizontal distance is going to dictate where you're going to be on the color. So we say, okay, p dot x, and then the range. Well, if we look at our geometry spreadsheet here, we can see that the the points at the end here have a x value of negative 2.5, and then the points over here have a value of 2.5. So maybe we could go negative 2.5 to 2.5. Okay, that kind of worked, but all the colors are the same. We can see that all the numbers in the color attributes are the same. So maybe, what if we kind of pull this up and pull this in like this? It's not really kind of doing what I want. Okay, there it kind of did. but it's hard to control, right? It's very difficult to control. I could kind of mess around with these values. Maybe what if we do like 0, okay, and then what if we do 10? What if we do like negative 10 to 10? Okay, that doesn't really work. So you see, it starts to get a little tricky here. So this is where we have to think like a computer. And a computer does not understand the words color the ends of this geometry. You have to give it very specific instructions. Very specific. And so what I'm going to do is I'm going to say, you know what, computer? You're good with numbers. I'm going to give you a number. And if that number is a low number, color it black. If that number is a high number, color it white. That is what the computer understands. Low number, black. High number, white. It doesn't understand, hey, could you color the ends of this geometry for me? It just has no concept of that. Maybe in the future, maybe that's kind of one of the exciting things about AI, and I think where it could potentially help artists a lot is if you could have a conversation with like a computer AI assistant and you said, hey, you see this sculpture I'm working on? Go ahead and, color the top of it, color the head, you know, you know, I don't know, maybe it's an alien, so like green, right? And the computer can kind of analyze the sculpture and look at the head and think to itself, oh, let's see, based on all this knowledge that I know about, animals, like I think this is probably the head. I'll color that green. That may be in the future, but we're certainly a bit limited now as far as what we can do. So, how can we do this? So let's think about this. So let's break it down. So, what we really want to do is we want to give these things at the end. We want to give them low numbers, and we want the things in the middle to have high numbers, right? Well, we have a start here, right? We've got primitive numbers, right? Each one of these primitives has a number associated with it. And this one has a low number. That's what we want. But we want this number here we want the highest numbers to be in the middle. We don't want the we would rather have, instead of right now we have low numbers down here and really high numbers up here, we'd rather have like low numbers here and low numbers here and then bigger numbers in the middle. So let's think about how we could do that. So every primitive, it knows its number, right? That's something called at. I think it's prim num. Let me just. So I'll say an integer value, which is your name, is equal to your primitive number, and let's do at name. We'll do I at name is equal to name. I just want to write this out so I can see it. Okay, that didn't work. So, let's see. Didn't like that. Prim num. Okay, I didn't like that. Maybe it's prim num. Maybe like that. Yeah, there we go. So this is kind of one of those tricky things about Houdini is there's all these. So you turn on your primitive numbers and you see that every primitive has a name, but you're like, okay, how do I have access to that, right? And it happens to be this at prim num attribute. That's on every single primitive in your scene has a primitive number. It just has to have it. So you can access that there. And you can see here now, these are the primitive numbers right here. And now I have an attribute called name, which lines up with it. Okay. So, just to show like the power of this. So now if we drop down a color and we say, hey, get it from an attribute. We're dealing with primitives, and the attribute will be your name. Okay? and we want low numbers to be black and high numbers to be white. Well, now now it's kind of working, but it's a little confused because it's like, well, the lowest number I found was a 0, and the highest number I found was an 18. And we're telling it that the lowest number to look for is a 0 and the highest number to look for is a 1. But that's not true, right? The lowest number to look for is a 0, but the highest number to look for is an 18. So we actually have to tell the computer that. So we'll type in the range here, and now it's actually kind of working how we would expect. So now we have uh, you know um, we have these lower numbers here are being colored black, and the higher numbers here are being colored white. And with a little bit of adjustment, we can kind of color the end of that. Um, now, if we so now we want, but we want this end to be black too. So what's really nice about having this ramp, this is the part where the visualization really helps. So now we can put another black node up here, and so now we can get that to be how we want it. So you see, it took just a little bit of code. This is not very much code. If you think about it, I'm just saying, hey, what's your number? And then go ahead and put that into something called name. And then I'm gonna you literally I could I could probably do this in one line, but I just to kind of illustrate here. So we're creating an integer named name, and we're saying that is equal to your primitive number. All right, so these right here, these numbers. And then I'm saying, okay, I need an attribute. So how do we create attributes in Houdini? We say what type of attribute. So I stands for integer, F stands for float, V stands for vector, right? You want to make sure you're really familiar with that stuff. And then we use the at symbol, which says, hey, I want to make an attribute. Because what this will do is it will say, hey, is there an attribute called name already on your geometry? Oh, I don't find it. I'll make it for you. It's really cool like that. See here, when we did at prim num, notice that when I put an underscore here, notice how it created it for me, because there was nothing called prim num before. But if I type in the name of the attribute correctly, it says, ah, I see. You are trying to find an attribute called prim num. Okay, I found it. I'll go ahead and get that for you. Okay, so Vex is really elegant in that sense, in that when you make an attribute, it will try to look for it, and if it can't find it, it will create it for you. So that's pretty cool. So that's what we're doing here. We're saying, okay, we'll go ahead and we'll make an integer attribute, and we'll call it name, and we'll set that equal to the value here that we created, which we found. Okay? And now, remember what I said about the computer? The computer does not understand color the ends of these things black and the middle white. But it really likes numbers. So now we have a nice number that we can give it. We can say, hey, computer, I know you like numbers. I've got a number for you. It's called name. And guess what? The computer's like, oh, yay, I love numbers. Okay, tell me, what is the lowest number I'm looking for and what's the highest? And then we say, yeah, computer, no worries, we gotcha. The lowest number you're looking for is a 0, and the highest number you're looking for is an 18. And so then the computer's like, awesome, I found it. I found the low number and I found the high number. Okay, what do you want me to do? And then we're basically, what this ramp is doing, we're saying, okay, computer, those super low numbers that you found, go ahead and color those black. And those super high numbers you found, go ahead and color those black as well. In the middle, the closer it is to the exact middle, so for example, because this is between 0 and 18, the middle numbers will be like 9 and 10. So we'll say those middle numbers, go ahead and color those white, and then the further away you get from the middle, start to go ahead and color that in. Now that is something that the computer can understand. So I hope that makes sense. So if I just drop down a simple color node and I start making the ends black and white, again, it's totally understandable why someone would think that that would color the geometry that way, because again, we have to be really careful. We're somewhat limited in the way that we perceive the world in that we are human. So everything that we are observing through our neural network that is our brain is being filtered through the lens of us being humans. Not to get too philosophical, but that's kind of how I think about it. Whereas a computer, the way that a computer sees the world is in zeros and ones. Okay? So you got to talk to it in numbers. Now, there's some really, really smart humans, some really great creative humans who have made all sorts of tools that that kind of bridge the gap between the way we see the world and the world of the computers, which is the zeros and ones. But in visual effects, when you want to have that precise control, you have to be able to talk to the computer in a language that it understands. And that is why I personally recommend learning how to use coding in your visual effects work. You can be a you could be a hundred times better visual effects artist than me and not know a line of code. Okay, I am not saying that learning code makes you a good visual effects artist. I'm simply saying that visual effects are created by computers. Computers understand code. Because of that, I have found that I can talk to the computer by learning the code. It would be the same way, like, if back in the day, if I was like a practical effects artist, and I was working with like another effects artist, and let's say we were like working on Jurassic Park, right? And we're building the T-Rex. Well, what language are we going to use to communicate? Well, we're probably just going to use our speaking language, right? I'm going to tell the other artist, hey, like, I'm working on the head. I'm going to make it about this big. So can you make the neck this big to compensate? And that's a language that we have that we could communicate in. And the best part about that is I don't even have to like reframe my thinking, because I can just tell the person what I'm thinking. Now, if I'm working on that same effect with the computer, and I say, hey, computer, I'm going to make the head about this big, so could you make the neck this big? Computer's going to like freak out. It's gonna not know what to do. So we have to think about it from a computer's perspective. Well, what would a computer understand? Well, a computer likes numbers. Maybe I can tell the computer, hey, computer, I'm going to create the head with this diameter and this radius. So can you maintain that relationship with the neck? So for example, if the radius of the head is 2, could you make the radius of the neck 1? And then go ahead and maintain that relationship, right? So as I make the head, bigger, let's say 3 meters in radius, now can you make the neck 1.5 to compensate? And the computer's like, oh, I can do that. I can do that. That's just maintaining a mathematical ratio of 2 to 1. That is something I can do. And so you have to kind of, it takes a little bit of imagination, but if you kind of think about the world through the eyes of a computer, you will run into far less frustration when you're coding. And you'll realize that, the computer's trying its best. It just only knows how to communicate in a certain way. And it's up to us as humans. Thank God we have the imagination and the creativity to be able to see the world through the way they see it so that we can talk to them. So anyway, this simple example basically just kicked off that entire thought process in my head, and I thought it was kind of an interesting one, and I wanted to kind of make a video about it and share it. So I hope this was helpful, and yeah, fun stuff. I like thinking about these things. So anytime I get a example that makes me think about things in a different way, I always like trying to share it with people. So that's my video for today.